Dependent events. Coach Cruz is responsible for randomly selecting a captain and co-captain for the volleyball game to participate in the coin toss. There are 12 players to select from. Coach Cruz says that each team member has a 1 in 12 chance of being selected. Determine if you agree or disagree with Coach Cruz and justify your answer. So if there are 12 players, not everyone has 1 in 12 chance, because once the captain is selected, you're missing a person. So like if you start with 12 people and make the first selection, how many people's left for the second selection? 11, and so forth. That leaves only 11 for the second selection. And so on and so forth on down. When you take the select one, the second selection, then you're left with only 10. And it keeps going down to the 12. So the independent probability is when outcome of one event does not impact the outcome of the second event. These events are called independent. That's where the probability of A is the time the probability of B. Now, the dependent probability is when the outcome of one event impacts the outcome of another. It is a dependent event where you get the probability of A, and then it's the probability of B after A. And you'll see that. It's not hard. Okay. So let's read these situations and determine if they're independent or dependent. Flipping a coin results in one landing on heads and one landing on tails. Well, you can't take half a coin away, so that's going to be independent. Because if I flip the coin, I get it on tails, and if I get it again, I can also land on tails. So that's independent. Anita reaches into a drawer with necklaces and selects 2 to wear. So if let's say for instance there's 6 necklaces in the drawer, Anita reaches in and picks one, that only leaves 5 necklaces. So the result of the first one does impact the second one. So that's dependent. You draw a joker from a deck of cards, and then you draw an ace. Okay, if you add the jokers, I think there's 2. There's 52 decks in a card. So if you add jokers, that's 54. So if you pulled the joker out once, that only leaves 53 cards. So it does impact. So that's dependent. You draw a queen from a deck of cards, replace it, and then draw a 10. Okay, you draw that queen out, so that left 51 cards, but you put it back, so it made it 52. So that's independent, doesn't impact. A 3-digit password can be any combination of numbers. One doesn't have anything to do with the other, so that's independent. Yep, one set of numbers for the first number, one set for the second, and one set for the third, and they don't have anything to do with each other. All right, number 2 down here. Use your understanding of dependent probability to answer the questions below. Number 2, Neil goes to the pet store and selects a treat for his dog. He chooses one and then chooses another. What is the probability that Neil selects a bone and then a ball? So how many possible outcomes does he have? 1, 2, 3, 4, 5, 6, 7. We have 7 possible outcomes to begin with, and he chooses a bone. 1, 2, 3. All right, he took a bone out of there. Okay, so he took a bone out. So now we only have 6 in the possible outcome. And how much is a ball? So that would be 2. So you take away 1 if you don't replace it. So 3 times 2 is 6. 7 times 6 is 42. And that simplifies to 1/7 because each one of them are divided by 6. Right. Number 2, Mackenzie chooses one candle and then chooses another. So Mackenzie didn't replace it. What is the probability that Mackenzie selects a polka dotted candle? So we've got 1, 2, 3, 4, 5. And a polka dot is 2. So we're going to take one polka dot away, and that leaves 4 candles. And what's the problem? A polka dot both times, which would be 1 out of 4, because that's what's left. And that would give you 2 times 1 is 2, 5 times 4 is 20. Those are both divisible by 2, so that gives you 1/10. Number 4, Miss Moore is doing laundry and has various pieces of clothing in her laundry basket. So our total outcome is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16 total pieces. Up there in the corner I put. What is the probability of selecting a top and then selecting a bottom? See how many tops do we have? We have 1 top out of 16 pieces. Okay, now we only have 15 now because we took the top out, and then a bottom. So how many bottoms? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. 1, 2, 3, 4, 5. 5 out of 15 in the bottoms. 1 times 5 is 5. And 16 times 15 is 240. Both of them are divisible by 5. Gives us 148. We reduce it, divide it by 5. All right. What is the probability of selecting a striped sock, replacing it, and then selecting another? All right. So we've got out of 16 possible, a striped sock. 1, 2, 3, 4, 5. And we replaced it, so we put it back. So the next pull is out of 16 as well. And it's also 5. Because there's 5 striped socks. Because we put it back. So that's 25. 5 times 5 is 25. And 16 times 16 is 256. And 25 don't go into that, so that's simplified. What is the probability of selecting a towel, replacing it, and then selecting the towel again? There's only 1 towel, so 1 out of 16. We replaced it, so we're still in 16. So that's going to be 1 out of 256. What is the probability of selecting a skirt and a top, one choice after the other? So for skirts, we've got 2 out of 16. And we're selecting another, so this one's going to be 15. And then a top, one choice after the other. And how many? We only have 1 top. So we multiply those. 2 times 1 is 2, and 16 times 15 is 240. And that simplifies to 1 over 120 when we divide it by 2. What is the probability of selecting a matching pair of solid socks, one choice after the other? So our total choices is 16 of solid socks. 1, 2, 3, 4. That's 4 out of the 16. And then 1 right after the other, we didn't replace it. So then that would only leave 3 because we would take 1 set out. And that'll give you 12 over 240. That's, both of them are divisible by 12. So that's going to give you 1 out of 20. And the last one, Mr. Wilson tells her fourth grade class that she'll be assigning them seats as they come into class tomorrow. There are 20 desks with 5 desks in each row. She asks them to find the probability that the first 2 people to enter the class are assigned seats in the front row. Circle the name of the student who did this correctly. All right, so if you start off with 20 and there's 5 desks, so you got 5 desks out of 20. But once you assign the first desk, how many desks does that leave? It only leaves 19. And then 19 desks altogether with the 4 in the first row. So when you do that, you get 20 over 380. And that simplifies to 1/19 when you divide both of them by 20. So the answer's Marcella.